Hey ChemStars, welcome to your Chapter 9 video homework solutions, Level 1, page 12, and page 13, but I made a mistake. Page 13 is actually repeats of problems you already did. Number 3 on page 13 is a repeat of page 8, number 4. Sorry, if you want more practice, work it out here, then go back to your solutions from that page. And number 4 on page 13 is a repeat from page 9, number 6. So extra practice there or some scratch paper if you need it. Let's work on page 12 right now. So let's look at the first problem. It says, find the mass of benzene, C6H6, so I'm looking for question mark grams, required to produce 2.66 grams of carbon dioxide gas at STP from the reaction described by the following equation. Remember that at STP, it just tells you its standard temperature and pressure. It helps normalize some things with gases. Don't worry about that. We'll get to it in chapters 10 and 11, gas laws. So let's look at the equation. Is it balanced? Well, 6 carbon, 6 carbon, 6 hydrogen, 6 hydrogen. Then we got to count up our oxygens. 3 times 1 is 3. 6 times 2 is 12. 12 plus 3 is 15. I've got to get 15 oxygen right here. So you can throw in a 7.5. If it makes you feel better, go back and double everything. If not, just keep going. We need those ratios. Okay, so let's look at the BCA table. Before, change, and after. Before the reaction starts, we're going to assume we have more than enough oxygen from the atmosphere around us. Before the reaction starts, I have no products. I haven't produced anything yet. But before the reaction starts, there must be some number of moles of benzene. We don't know that. That's what we're trying to solve for at the end of the problem. So we're actually working backwards. They told us how much of the CO2 was produced. Oops. So they're giving us this number, essentially. So 2.66 grams, I need to divide by the molar mass of CO2. Remember, this number, the 44.01, that comes from your periodic table. Take carbon plus oxygen, add them up, 2 oxygen, you'll get 44.01. So let's take our calculator, and we need to get 2.66 divided by the molar mass, and we're going to get 0.0604. So 0.0604. That's how many moles of my CO2 was produced. Okay? We know we started with none and we ended up with that much. So how much was created during the change? Think back to your problem setups. It's going to be question mark, the coefficient from that ingredient of the benzene over there, times the ratio of CO2 to benzene. This is where you could use 6 over 1, or if you doubled everything, it would be 12 over 2. I'm having a flashback. Is this problem a repeat too? I don't know. We're going to go ahead with it anyway. So let's see. Okay. So question mark times Ollie. Hi, Ollie. Ollie's coming by to check out your homework problems. So question... Oh, hello, Ollie. Good boy. He's offering you some stoichiometric encouragement. How about that? So question mark times 6 is equal to 0.6042. So how do we get the question mark by itself? Well, we divide each side by 6. If you need me to write that out, I will. So 0.0604 is equal to question mark times 6 over 1. So then we need to divide each side by 6. So divide by 6, and that means that question mark is going to be 0.0100. So let's just say 0.01. That's what my question mark is. Okay, so question mark 0.01 minus 0.01, that's how much is used up. There's none left over. So I've got 0.01 moles of benzene. And then they want to know how many grams though. So we need to figure out the molar mass of benzene. So go to your periodic table, C6H6. So, oops, I'm on the wrong tool here. So we need to get C6H6. That's going to be 6 times 12.01 plus 6 times 1.01. So 12.01 times 6 plus 6.06, 78.12. 78.12 grams per mole. So 78.12. Now, in the interest of being methodical here, let's get that original number back in our calculator. 2.66 divided by 44.01. That gives us the 0.0604. Now we want to divide that by 6. That gives us that 0.010 number, just so we can be specific with sig figs. So that's our number of moles of benzene times the molar mass of benzene times 78.12. So how many grams of benzene do we have? 0.786. And we need to have 3 sig figs, so 0.7864. 0.7864. Look back to the original problem. Here's your 3 sig figs. 1, 2, 3. So the 4 won't round the 6 up. Our final answer is 0.786 grams of your benzene. Good. And if you want, you can fill in the rest of the BCA table, but I'm only filling in the parts that answer the direct question that we were asked. One problem before we're done with this video. Okay. So we have potassium superoxide. It's utilized in closed system breathing apparatus, so something maybe think like a submarine or like a space shuttle, to remove carbon dioxide and water from the exhaled air. The removal of water generates oxygen for breathing by the following reaction. We're asked to calculate the mass of water that must be removed to form 3.5 grams of oxygen gas at STP. Okay, there's a lot of extra info, but let's really break it down to what we need to know. So here's our chemical equation. Let's see if it's balanced. Okay, the first thing that we want to look at is that, see how there's H2 here? I need to get H2 right here. So put a 2 in front for your coefficient. That takes care of hydrogen, but that just gave me 2 potassium. So let's throw a 2 over here. That gives me 2 potassium. So right now, I know that potassium's good and hydrogen's good. Now we just got to count up and balance our oxygen. So here there's 2 times 2, that's 4, plus 1 is 5. I have to get 5 total oxygen on this side. Well, right here there's 2, so that means I have to get 3 oxygen from right here. So whatever can go in front, 1.5. If it makes you feel better, go back and double it. So make it 4, 2, 3, and 4, and that'll work. Okay, so let's see what we actually know from the problem. I know that before the reaction starts, I don't have any products, I'm producing them. I'm going to exactly use up that amount of water that they want. They want the exact mass of water needed to remove 3.5 grams of oxygen. So I'm trying to figure out what this number is right here. They gave me grams, I need to go to moles. So 3.5 grams of oxygen. Oxygen is O2, remember. So we need to take 3.5, divide by the molar mass, which is 32. We're going to get 0.109. And that's going to be your moles of O2. So right down here, we produce 0.109 moles of O2. Now, how much did we initially start with? 0. This much was produced. Now, we're trying to solve for that same question mark working backwards. So the ingredients, the moles of the water, which was the limiting reactant over here, it's going to be times the ratio of the oxygen to the water. So we're trying to solve here. So question mark times 1.5 over 1 is equal to 0.109. So what do I have to do to each side? Divide by 1.5. So question mark divide by 1.5. Question mark is going to be 0.0729. So 0.0729. That means that during the change, I used up 0.0729. At the beginning, I started with 0.0729. There's none left over. Okay? But they don't want to know moles of our water. They want to know the mass. So we've got to take that same number, 0.0729 moles of water, which we just solved for, and multiply by the molar mass. So hopefully that same number is in your calculator. Multiply it by water's molar mass from the periodic table, and we get an answer of 1.313. 1.313 grams of water. They want 2 sig figs. So right here is our 2 sig figs. So 1, 2. The 1 can't round up to 3. That means my final answer is 1.3 grams of water. Good. We're done with page 12. And remember, page 13, they are repeats. If you want to try them for practice, go back to the page 8 video, problem number 4 for that solution, and go back to the page 9 video, problem number 6. I'll see you next time. Don't wait to be great. Bye, guys.